Question number 3. In an ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. True or false?
I was thinking true.
I also think that.
Sounds right.
Because if I remember from her review and the chapter, HO is always that all the means are equal to each other, and
Yeah.
hypothesis is at least one is different.
Yeah, it says that in section 3, I think. So, and then the question after that just wants us to mark the requirements that need to be checked when performing an ANOVA hypothesis test.
There's only 2 of them, right? So 2 of these will be correct.
Yeah.
And one of them is that data is normally distributed.
And then the other one is the variances are equal.
There we go. Yeah. Now, what kind of plot do we construct to confirm that they are all equal? It is a QQ test, right?
Mm-hmm.
QQ plot, yeah.
Yeah, QQ plot.
Yeah. Okay. For number 6, we assume the variance in each group is the same if the following happens. The sample for each group is smaller than the sample mean. The largest is less than 4 times the smallest. The largest. What?
Isn't it that one, the second one that you read, the largest is less than 4 times the smallest?
It's either 4 times or 2 times. I was trying to remember.
Let me pull it up again. I just saw it when I was scrolling through. So it's in 3.2, and it says if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Yeah.
Oh, okay.
I had just gotten to that point in my scrolling as well. Double checking.
Like, I remember, like, some of the formula, kind of, that it's a number times the smallest.
Yeah. Okay, so question 7 says an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
1, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. So 6.
That's how that works, isn't it?
That it follows the same rules that there'd be each pair is matched up only once with all of the others.
Yeah, I think 6. Yeah, because if you follow their same logic, that only one pair can match up together.
Yeah, because 1, 2 would be the same as 2, 1, so we wouldn't double count that, so 6 should be right.
Yeah.
Now we go to the information in soccer shoes.
Um, do you guys know when our test is? Is it next week?
This week, isn't it?
It's Thursday. Well, it opens Thursday.
No. I feel not prepared for this at all. The last one I didn't even study for and I was just fine, but I still don't know what's going on with any of our stuff. Past chapters. Are you guys getting yours to open?
Yeah.
Mine decided to freak out, but now it's open.
Okay, mine kind of did the same thing, so.
It said failed to log on. Now it's open. Now it's really working.
I'm so hungry.
So on the automatic recode,
Yes.
which ones did you guys do? Footwear, right?
Yeah, that's what I did.
There we go.
And then we moved kicking accuracy into the dependent list, right?
Yeah, that's what I did.
Okay.
Hey guys,
Hey.
I'm late to the party. How far have you guys gotten?
We are on question 8.
Okay.
So what did you put in the factor box, Miranda?
Um, I put the footwear, like the new code, whatever you named it.
Okay.
I called mine foot code, so whatever you changed yours to.
Or you're gonna have to meet.
I didn't get. Oh, there it goes. Okay, never mind. So on your output, you just got the chart that says descriptives, and then the one that says ANOVA, and a means plot.
Yeah.
Okay. Sweet.
And then I'm not completely sure. Are we looking at the means or the standard deviation? The standard deviation.
I am trying to figure that out.
Okay, because so far I don't know where it's at in this book.
So
Yes.
the only thing I really understand how to, like, I get where everything is, but I only get the QQ plot thing. I don't feel like it's explaining the other stuff very well.
Yeah.
Right. Well, the well, if I did this right, the total minimum I see is 19. So,
So we think it's the minimum, it's not the lower bound.
what I thought, but I don't. I'd have to look.
Oh, yeah, no, I read the question wrong. Abby, how's yours coming along? Is it?
I'm putting in all the information right now to do the analysis. So
Okay.
I'm almost there.
Okay.
Okay, so far I did the one-way ANOVA test, but I haven't done the analyze descriptive statistics in the Explorer. That part of it, if that makes sense.
Yeah.
Should
Yeah.
I do now, or should I keep up this?
I don't think I did to the explore part.
Okay, okay. So hopefully I have the same numbers as you guys.
Do you guys all have 19 and 48 for your max and min?
That's what I got.
Let me.
What was your max again?
48?
Yeah.
Okay, so I have a minimum and a maximum off to the side, but I think maybe I did something wrong because I have like a bunch of rows of minimum and maximums. Should I only have one?
No, you should have a lot. There's the mins and the max for all of the different
Oh,
groups, and then
the
the
total.
bottom one has the total.
So 19 and 48 is what I have too for the total. Sorry, guys. Okay, couple answers then.
Remove the SOX data and then do it again.
So I'm having a hard time knowing how we decide if the test for equal variance is satisfied with the data that we're given. Maybe I'm just missing something in the book, though.
Yeah.
I have trouble whenever it comes to like the logical stuff like that. I can follow directions, but whenever it takes brain power,
Yeah.
I have to think about it.
But wasn't it satisfied because the maximum was less than 4 times the minimum, right?
Sure. If you say so.
It sounds good, Jake.
It seemed like the text was saying you guys satisfied keeping all the data in less than 4 times of each other.
So we should go with that one.
Sure.
And then
How do we analyze?
So, just on question 11, without constructing it, because the last question was false because it's not more than 4 times, isn't it gonna be false? Isn't question 11 gonna be false anyways because they won't be normally based?
well, each one of them could be normal. What can it think?
I don't know. That's what. Because how do you answer true or false for all 6? Because we know that like our total isn't normal because it's not more than 4 times.
I thought it was normal because it was less than 4 times. I don't think it's true.
I don't know. There's just the part in section 4 where it says like down at the bottom.
Yeah.
It says since the largest variance is not 4 times larger than the smallest variance, we can assume the variances are equal. Oh, so maybe I read that wrong. So wouldn't it have to be true then?
I would.
I would
Sorry,
so.
we just confused everybody because I had myself confused.
Like there is a
Good.
way that you can make a QQ plot for each one of them, and it says how to do it in 3.3 box, but I don't know if you really want to do that.
I was trying, but
Good job.
I mean, there's a little sketch. If we can do, I
Okay.
would rather do that.
Okay.
But I'm a little intimidated by question 12.
Me
Yeah.
too.
Because I'm like, didn't we just perform the ANOVA test?
Well,
Yeah, but we have to do it without sock.
Yeah.
The one I got was 0.309 after deleting the sock data.
So this might sound like a really dumb question, but how did you get rid of the SOX data?
I
Did you
highlighted
just-
it and then hit clear.
Okay.
So on your what? Where did you highlight it and then hit
I
clear
went
from?
back to the document where it lists all the data and highlighted it and cleared it.
Did you highlight both box with the accuracy too?
Yes. Anything
Okay.
on those?
It is real, guys. It really did. It destroyed all my socks.
Oh no! Now you have no sock? Whoa.
You left everything in the footwear code. I think I did something wrong.
Other than that, I did the same, and then it. So then there was only
Okay, I got some numbers, but
funny thing is my minimum and maximum are still 19 and 48 having done that.
wait, mine are still the same too. Let me find.
But then it's at the bottom where it says picking accuracy, it changed to 0.309 instead of the 0.8.
Okay, so that's what I have too, Jake. So hopefully that means something, right? 2 people. That's good.
That's at least
Maybe.
half. So after you did that, you just went to analyze and then compare means and the one-way ANOVA thing.
Yeah.
Yeah, everything the same, just take away the sock stuff.
Okay.
So is sig the p-value? That's the two-tailed p-value, right?
Yeah.
Oh,
Yeah.
I think I did something wrong. I'm still getting 0.81.
And the little sig section,
Yeah.
did you clear both columns of the sock stuff?
Yeah, I cleared footwear and accuracy.
huh.
Oh, actually, okay. Okay, wait a minute. Go down further, Emily, because on one of my spots, it still says, like my first ANOVA section says 0.081, but then further past this little chart, line graph, I should say, I guess, then it shows 0.309, and it's a different, like, little line graph. Does that make any sense?
Yeah, it did, but I don't think I have that.
Okay.
I'm just gonna reopen the thing. And see if I can get it to work that way.
Okay.
And then how do we know if it's left or right? Oh,
That's what I was just thinking.
I am unsure.
for ANOVA testing, we use the F distribution, which is right skewed. The p-value of an ANOVA test is always the area to the right of the F statistic.
So then are they just quizzing us?
Yeah, then they're just making sure we know it's always to the right. I think
Okay.
that's what the book says in the summary section. So I go on with that.
Sounds good to me.
Hot dog.
Oh, but it wants us to do Q and Q plots for question 14.
Yup.
We need to, because it'll probably ask us to do it on the test, and then we'll have a panic attack.
Most likely. But I still like the lazy way out of it.
No.
So
Okay, so
what
guys,
is it?
just really quick, tell me what you got again on question 12.
0.309.
Okay, that's what I got. I don't know what I did wrong the first time, but it works that time.
At least it worked.
Okay.
Okay, so it wants calories. I was confused. So 3 types of hot dog. So how do you split up the hot dogs?
I just downloaded the data. I haven't got that far.
By calories first, I guess.
Yeah, but they're all like lined up together like beef, meat, poultry.
Oh,
So I feel like you need to separate them some magical way so you can make a QQ plot.
that's what it told me I had to do. Want them to do it.
So you did it
somehow-
by calories, not by type?
And move the variable that specifics the group into the group. Oh, so do I need a decode? Do I need to
that's what I was gonna ask you guys. I'm gonna assume so because that still isn't all the steps, but I don't know.
Yeah, because like it says to put in, move the variable that's the groups into factor list box. Click on plot and then plot in the web test. So I guess be safe and recode them.
But I didn't. Do you just recode according to calories?
I was going to recode the type.
Is that what you did too, Jake? Just recode the type?
Yeah.
And then analyze. Continue. Okay. There it goes. No.
So on you guys' mean plot, just to be sure that I did it right, does it look like an upside down and backwards L?
Which one?
On the mean plot?
Oh. Let me scroll that back up to that one.
I don't know.
What did you say it looked like?
Like an upside down backwards L?
Upside down, backwards L. Actually, slightly. Well, yeah. Hmm.
Except more like weird, yeah.
I guess.
Okay. I thought that was the easiest way to be sure that I did it right.
So yeah, I was able to get all my QQ plots.
Well, good. So what can we determine from the data?
I take it that you didn't, Jake.
No, mine decided to freeze on me, and so I have to reload it.
Oh
I know.
no. It's safe to assume each.
So you moved the type code, or like the thing that you renamed, you moved that into the dependent list?
No, I put calories in the dependent list.
Oh, no. Okay,
And
yeah, I was being stupid, actually. Because it's
I
dependent.
put the new code into the factor list.
Okay.
I say the assumptions have been met and they look normal enough to me.
Okay, so in the instructions it says mark the box next to normality plots with tests. I don't see that.
So you have to click to the right. There's buttons. You have to click the plot button.
I did, but
It's kind of in the
oh,
center, like the center bottom
Yeah.
half.
okay. Okay. Got it. Thanks, guys.
You said we're also assuming the variances are equal because they seem fairly normal.
Oh gosh, there's a ton of data with this.
Yes, there is. And you just gotta scroll all the way down to the
QQ.
normal QQ. Because if you scroll past the normal, there's a different kind of QQ plots.
I guess I still don't get why we have to make QQ plots if the way that we're checking if it's normal is still to see if the min and the max are 4 times greater or less than each other.
Yeah.
Because they want us to waste our time.
Because right after you make that, it's like, right after you go through all the effort of making that in the book, it says we'll use a very simple test to determine if they're normally distributed, and that's how you do it. So.
I know.
I realized in math they always give you the long and complicated way and have you learn that way, and then they teach you the shorter way.
Yeah.
It's very annoying sometimes as a tutor because I'm like, I just want you to know this way because I don't want to go through this long process with you.
Emily, did you see down there? Well, after in the book it says about the 4 times thing. It says how to find the variance using SPSS.
Yeah, that's kind of the same thing, isn't it?
That's what I was thinking. I don't know. Is that like what we should do instead?
That's what I'm confused about. Like, why do we have to do this? If I'm sure this has a purpose that I'm not seeing, but I'm.
Look for the descriptive table is what it says. But oh, it does have a variance number in the descriptives. There's a variance number for each of the different kinds of I guess types of hot dogs, like the meat or the poultry or the beef. But I guess I'm not sure what are we supposed to do with those numbers.
I don't know for sure. So what did we decide for question 14?
I was thinking the first one, but it's been met. Because plots look normal.
The only one that doesn't look normal is the beef one. At least to me. Oh, okay. No, what QQ plot was I looking at before? There's one of them that doesn't.
Are you looking at the normal QQ plot?
Oh, yeah, that's the one that said not to look at. Okay. Never mind.
So is it number 1 or number 2 though? Because number 2 says they could be normally distributed, but we can't assume that the variances are equal. So it'd be one of those.
Oh. I guess you can't assume that the variants are equal to each other just by looking at the QQ plot. Could you?
So what are you thinking? Do you still think the assumptions have been met?
That's what I was saying.
If the book actually did its job and explained,
I know. I feel like the book is a little bit of help. I know they try to do their best, but no matter what, there's always like further explaining needed with online classes, I feel like.
Yeah.
I guess, that's why we have professors and stuff.
So we're gonna go with the first one though, right?
Yeah.
Okay, but this
Makes sense.
doesn't it?
So then we run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. We should find the degrees of freedom to be 2 and 51, that F is equal to 16.074, and that P is a very small number with a level of significance equal to 0.05, which leads us to what conclusion?
I was thinking the second one.
Because we have to reject the claim, don't we? Because of the level of significance. So it has to be one of the reject ones, right?
Yeah, but there's only one we do
Yeah.
not have significant evidence.
Yeah.
Yeah.
Right.
So we just roll with that.
That's what I was thinking. Kind of seems odd that it's just one.
Now we get to examine the sodium levels, constructing plots of sodium levels.
Oh, I'm so excited to do this all over again.
And we should see the QQ plot for poultry suggesting a possible problem with the normality assumption. Smallest variance being 7,180.75 and the largest 10,492.871. Have the assumption been met to use ANOVA?
So it's got to be one of the questions saying that we can assume that the variances are equal, right?
I think so. I think that it's the first one again because the normal because the QQ plots look like it's normal.
I was trying to decide between the first one and the one that says the assumptions have not been met. It's not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal. So I was trying to decide between the first one and the third one.
Well, isn't if the QQ plot, if it's like close to the line, it's normal, right?
Yeah, if it's just going relatively straight.
I feel like it's normal for the most part, but there's like some spots that are kind of sketchy.
Well, let's just go with because they seem to be normal for the most part.
Okay.
So you're thinking the first one then?
I think so.
And then we have to do the ANOVA.
So question 17 is throwing me off though, because it says despite the possible problem with the QQ plot for poultry. So
Yeah, I
does
know.
that mean does that mean that it's not normal? Like, are we ignoring that too much in our answer on 16?
I guess so.
That makes sense.
So what do you think?
So do we think it's the third one that I was talking about? That it's not safe to assume each group is normally distributed, but we can assume that the variances are equal?
Yeah.
Okay.
So what was the p-value we came up with?
So I found 0.179. I don't know if that's right, but that's what I found.
That's what I got.
Did any of you guys see that as well?
Yeah, that's
Yeah.
what I got too.
Okay. Okay, so what conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? We're supposed to use a significance of 0.05.
So it's significant because it's greater than the level of significance. And then, according to her review video that she recorded and did, she says it's always the alternative hypothesis.
Oh, interesting.
So if it's significant if p is greater than the level of significance. It's not significant if p is less than.
That we do not have significant evidence to reject the claim that all 3 hot dogs have the same sodium.
I think we do because the p is greater than the level of significance. So I was thinking number 3.
Okay, I'm gonna submit my quiz.
Okay.
So I missed 5.
Oh,
We missed question 18. We missed question 15. We missed question 12. And we missed questions 8 and 9.
Great.
I'll be right back for just a second, guys.
That is so sweet. I'm proud of you guys. You guys should be happy. Tonight to celebrate, huh? That is legit. Okay. Okay.
Okay, I'm back.
So you said 18, 15, 8, and 9. And what was the other one that we got wrong?
Question 12.
Okay, this might be a really dumb question. But on question 7, what did you guys put?
6.
Okay, explain your logic.
So there's, in the example, it says there are 3 pairs, 1, 2, 1, 3, and 2, 3. So
Right.
each number can't match up with the second one twice, and it can't be matched up with itself.
I see. Okay. That makes more sense.
So on number 12, do we need to cut it in half?
I wonder if we're doing something wrong when we remove the data.
That makes sense too.
I'm really confused about what we did wrong on 8 and 9.
Yeah, I thought those were like no-brainers.
Yeah.
I don't know. Apparently, I missed our whole discussion last time. Group project that we're working on.
Yeah, that was at the very, very end, the last time we met. And I can read you guys what I talked to Sister Wilkinson about it, but I don't know that that's going to work out because she's wanting some different stuff. Let me pull up the email real quick.
Yeah, she was wanting more data, right?
Yeah.
Yeah, part of the requirement was that that we all have to be a part of collecting the data. So I
Which
mean,
I
like you
don't
could.
understand.
What'd you
Well, we all
say?
found at different places. We could pick a variety of items based on where we shop.
Yeah. Oh, you guys got all the emails, right?
I got
Yeah.
the
Okay.
It's more of me and you are in the same location.
Yeah, you could do different stores like Walmart versus Brawlham's, but I don't know. We can do something different. Like it doesn't even have to be that. I just knew that I had that data, so if we could use it in some way, then we could. But if it sounded like it was going to be almost more complicated to use that than if we just did our own thing.
right.
Yeah.
So we can do. I don't know if you guys have any other ideas or anything you're interested in, but we can do. I'm like totally open to whatever. But grocery stores might be something easy to do.
Well, I like your brother, or not your brother, your husband's textbook prices idea because that's something that we could all, like, we could all just get on different websites and compare them,
That's true.
like, regardless of our location.
Or like what? So like me and you, Emily, could do 2 different websites, and then like what if Miranda and Jake, they went to the university store and the Book Viking, because that's in Rexburg.
Yeah.
Yeah, I think that's a good idea.
We could do that.
Yeah, I'm
It seemed
thinking
like it was cool.
What?
It seemed like it was pretty simple
Hmm.
when he did it.
yeah. And now we just have to decide what books we want to do. Because we need to do at least 30.
We could do like foundation books, maybe. Well, there's really not a lot of books for the foundation classes. A lot of that's online.
Well, there's Math 108. If you do the World Foundations, each one of them have their own book set. But can you buy their book set?
That's the thing. So like on Amazon, you can't buy that book set because it's special for BYU Idaho. You could compare, like, you can get the prices from the individual books and put them all together, but you can't get the World Foundations 201 book on like Amazon, for instance.
Yeah.
Yeah, the World Foundations 201 only exists.
But we could pick like maybe we could pick a book from all of our majors or something and just do 4 different books.
You need the money
Yeah.
for it? Just the
Don't
book.
we have to have 30 items though?
Right. Well, I don't know. I know when like I said, when my wife was in this class, she said they analyze different colors in M&M packages.
Mm.
That's what you want me to do.
I like
That's a good idea.
fruit snacks and M&Ms.
So I really don't know what to do for our questions on 8, 9, and 12. Like, I don't even know how to go about changing those.
Wait. I didn't think I missed question 12. I didn't miss question 12.
What did you put on 12?
I put 0.309.
Frosting?
And I got it right. I thought we all put that.
I had a typo then, because I just put 0.039.
Okay, so it's just 309. Well, 0.309.
0.309. Yeah. Okay, my bad.
You're good. That was an easy fix. I wish they were all like that.
Yes. So then if 12 is right, what is the problem with 8 and 9?
I don't know. That's what's so frustrating.
Okay. I will see if I can get help.
Oh,
I'm going to be faster to call them.
Jake just emailed and said that his son unplugged his computer, but he thinks textbooks or colored candies could be really simple.
Okay.